Today we will be talking about the production of blue fuel hydrogen and blue fuel gasoline, both of which is said to be used as low-carbon transportation fuels. Based in Victoria, British Columbia, Blue Fuel Energy is a privately held company that is developing several world-scaled energy-related projects bridging our current carbon-based economy with a future low-carbon economy. Sounds good so far, but do you feel the same way when you hear that in order to produce blue fuel gasoline, natural gas from the hydraulic fracturing and horizontal drilling industry is required? Well, if you are skeptical, I have on the phone the CEO and president of Blue Fuel Energy, Juergen Puetter, to explain this complex technology, why he thinks we need it, and how it will be used as a bridging fuel. So prepare yourself for a chemistry lesson, because that is what it takes to explain this technology properly, and see how you feel about it later on. So, Juergen, I know I pronounced your name wrong again, but thank you for joining us.
Pleasure. Glad to be there.
So I think it's only appropriate if you give us a bit more of a background. I know the last time we spoke, you said that you were involved with a lot of organizations that are concerned about the environment. Could you tell us a little bit about your background?
Yes, indeed, I can. One of my primary occupations for the last 10 years has been involved in the wind energy business. I run a company called Aeolus Wind. We were the developer of the first commercial wind farm in British Columbia, the Bear Mountain Wind Farm near Dawson Creek, 102 megawatts, 34 3-megawatt turbines. And we have a number of other projects developed, ready to be built, waiting for the demand for energy to come along. And it was actually that activity with Aeolus Wind that gave ultimately rise to Blue Fuel. But prior to that, in my existing life, I have a long background with environmental organizations. I've been involved with Sierra Club and Western Wilderness going back 25 years, so when I first came to BC. So I have a long and strong interest in the environment, and I was initially much involved in activities regarding the logging industry. But what happened when I entered the wind energy industry, I found wind resources of extraordinary proportions in the northeast of BC predominantly, in the foothills of the Rocky Mountains, and was able to assemble a group of projects that far exceeded the amount of energy that could readily be expected to be put into the hydro grid. Because as you probably know, BC Hydro has a monopoly in BC. All power has to go through them, and they only buy the amount of power that they actually need. So currently it seems we have more than enough energy in BC. So the question was, what could one do with all this renewable energy that essentially is stranded? And as we all know, renewable energy suffers from a couple of setbacks. Two of them predominantly are one that it's not storable, the energy. The wind blows not exactly always at the time you need the energy. And two, you need to have wires to transmit it. So these two problems were paramount in our consideration as to what options exist there to store the energy. And we analyzed extensively over a number of years battery technologies and compressed air storage and what have you, and realized that a liquid fuel is probably by far the most energy-efficient way of storing energy, number one, and also has the ability for the first time to integrate renewables that are largely only in the electricity sector into the transportation sector.
Okay. Well, let's get to that liquid fuel, and we're talking about methanol here. You call this blue fuel gasoline, and just what I learned from your website, for a given amount of natural gas production, say worth $1 billion, instead of using it as a fuel in the natural gas form, Blue Fuel Energy plans to convert it into methanol, which would then be used to produce something called blue fuel gasoline, worth $10 billion. So, in other words, Blue Fuel Energy claims to be able to get 10 times the use of natural gas, making it, I guess, 10 times less carbon intensive. Do you want to start talking about the gasoline project?
Yeah, I'm not sure where this 10 times number comes from, but the first premise was we wanted to use renewable electricity to produce a fuel, and the way we can do that is by using electricity to split water into hydrogen and oxygen, because all our fuels are hydrocarbon, regardless where they come from. The hydro is where the energy comes. The hydrogen is where the energy comes from, and the carbon essentially comes along for the ride as a sponge to hold the hydrogen together. So when you burn a pure hydrocarbon fuel, the carbon comes out and the hydrogen is consumed in producing energy. So what we're going to do is take waste CO2, which is available in abundance in the Peace region when the gas comes out of the ground, and combine it with renewable hydrogen to make a fully renewable methanol. And we went many years at that concept to make 100% renewable fuel, but was unsuccessful to break through the financial barriers and acceptance in the marketplace. Today, there are no practical ways to use renewable methanol in the transportation sector because no methanol-ready cars are on the road today. So we then figured the only way to get into the existing infrastructure is to produce a fuel that we all currently use, namely gasoline. And making gasoline 100% from renewable turned out to be quite expensive. So as an interim step, what we then decided to do is to use natural gas as a feedstock to do the bulk of the production of gasoline and make it into first methanol, then dimethyl ether, and ultimately gasoline. And already just by doing that, we have already created a gasoline that is cleaner than the gasoline we burn today, because all BC gasoline comes essentially from oil resources. And making gasoline from oil has already a higher carbon intensity than making gasoline from natural gas. So there's already benefit there. Then what we did is we added electric drive to the process. You may be familiar about discussions about LNG where they're talking about using electric drive for compression or using gas to generate steam to drive the compressors. And we've taken the bull by the horns and right out of the gate we'll use 100% electric drive for the plant, again further reducing carbon intensity. But so far we don't really have much of a renewable component in there other than using renewable electricity from BC Hydro. As you know, it's probably about 90% plus renewable, mostly hydro and some wind. What we then decided to do is let's increase or decrease the carbon intensity of the gasoline even further by using renewable electricity to split water into hydrogen and oxygen and add the extra hydrogen into the fuel to reduce the carbon intensity. So the fuel we're producing is largely a natural gas-derived fuel with the addition of renewable hydrogen. And in the first incarnation, we'll be utilizing roughly 130 million cubic foot of gas a day, plus 60 megawatt worth of hydrogen to make just shy of 1 billion liter of gasoline per year. This gasoline will be the lowest carbon intensity, cleanest gasoline anywhere, and will not have used oil as a feedstock. It's a very substantial thing. Now the bridge... Yeah.
I sorry about that. When you talk about carbon, you have a low carbon gasoline. Isn't it the carbon that provides the horsepower? Won't vehicles just have to burn more reduced carbon gasoline to do the same job?
No, not at all. The carbon intensity, the energy intensity of our gasoline is no different than the gasoline made from oil. However, by displacing oil-derived gasoline with natural gas-derived gasoline, we have already made a benefit to the environment because natural gas is cleaner. Number two, we're using electric drive, which is further a reduction in the carbon intensity. And then we're adding renewable hydrogen. But the really big part is the renewable hydrogen. So initially, we're using 60 megawatt of power we'll be buying from BC Hydro to run these electrolyzers, which, by the way, at 60 megawatt will be the world's largest electrolyzer facility by a factor of 10. And we're doing that together with Siemens. But the beauty now is that over time, as we increase the capacity of the electrolyzer, we can back out more and more natural gas until ultimately, at some time in the future, and I can't predict exactly when, we might be making 100% renewable synthetic gasoline by not using any natural gas. That will come at some time in the future when the price of gasoline continues to rise over time and the price of electricity goes down due to the increase of more renewables. And then you'll have an economic proposition to make 100% renewable. And that's why we believe this project is a first bridge between renewables and fossil fuels anywhere in the globe that we know of. It's a very elegant construct with a great flexibility, and the ultimate goal was to build to make a fuel that has an existing market. Now, there are two more components that are important to understand. One is that British Columbia and California are two jurisdictions that currently have a low-carbon fuel standard. Today, the only way to comply with that is to take oil-derived gasoline and add ethanol to it. And ethanol, as you know, comes from food-grade biomass, mostly corn, some wheat, but mostly corn. And it has its own set of issues that I really don't want to get into today. But what we are now able to do is to make a BC-derived gasoline that is 100% made from local resources without us having to either import ethanol from plant, where we have the food-to-fuel issue, or have to import oil-derived gasoline. We think that's a very substantial step. In an ideal world, we would make it already today 100% renewable. But the problem is there are just not enough electrolyzers in the world right now to do that. The limitation is technology, that electrolyzers only are made today in a capacity of 2 megawatt per unit. So even for a 60 megawatt unit, we have already 30 electrolyzers in there. They're very, very large. And as technology improves and the capacity of these units goes up, we'll be adding more and more, thereby reducing the fossil fuel component.
Now, you were telling me that with the hydraulic fracturing, if you're an environmentalist, one of the concerns is the amount of water used in hydraulic fracturing. Could you explain how the production of hydrogen, you said you were actually producing your own water to do the hydraulic fracturing, is that correct?
Well, there's two things. We're producing enough water in the dehydration of the methanol that the plant has net zero consumption of water. That's one thing for the blue fuel plant. But the fracking component is even better than using our own water. We're reducing the water consumption. And the way this works is the following. If you look at the block diagram we have on the bottom of our webpage, you see that the input to make the natural gas-derived gasoline consists of natural gas and air separation unit derived oxygen. So we have a big plant that will consume 50 megawatt of electrical power that compresses and cools air and separates the air we breathe into oxygen and nitrogen. You probably know that 20% oxygen roughly and 80% nitrogen. We need 2,500 tons of oxygen per day to run the plant. So to do that, we also, as a byproduct, inadvertently produce 7,500 tons of nitrogen. And in the original analysis, that would be just released in the atmosphere because it's an inert gas and it goes back to where it came from, so really no impact. However, some clever engineering has occurred, mostly in the U.S. and in the shale gas areas, where there's considerable concern about the use of water. And you can use nitrogen as a substitute for water in fracking. It has a couple of technical advantages. The one advantage is that when you use water for fracking, and as you know, it's called shale gas, so when the water goes down into the formations where the gas is captured within the shale, you fracture it to make little crevices for the gas to flow by. But when you wet them, you expand them, the shale swells. When you use nitrogen, no swelling occurs. So you actually get more of the gas that's contained within the shale formation by using nitrogen. That's the good news. The bad news, of course, there's a cost to getting the nitrogen.
So do you have to use the chemicals with nitrogen?
No, but much less.
Much
and
less.
Also the water consumption is much less, so the amount of water you got to clean up could be reduced, based on my current understanding, by as much as 90%.
Okay.
So that's a big, big, big reduction. And you still need to have the sand, fine quartz material in there to keep the fractures open. Because when they fracture it, you pump some fine sand, that's called fracking sand, into these fissures to keep them open. Because if you didn't have them, they close up again, the gas wouldn't come out. It's I find it quite amazing that all of this works, and it's beyond my detailed understanding, but I have some cursory knowledge of it, and the idea of using nitrogen promises to be making the fracking process much more benign environmentally because you dramatically reduce the water consumption, the amount of chemicals required, and therefore the amount of cleanup you have to do afterwards.
Yeah.
So we think that's another positive step in the direction of making it less, having lesser environmental impact. Of course, our ultimate goal is to get completely away from natural gas, but that's going to take quite a time.
The website you were talking about earlier is bluefuelsenergy.com, so that's for any of our listeners that might want to check that out. But on that website, you have a YouTube link with another gentleman. I'm going to try to pronounce his name, Ayel Aronoff, and he was explaining the times 10 benefit of converting natural gas to methanol. And, and right. As he was explaining this, I could really see the dollar signs in his eyes. I mean, there's a lot of money to be made. Natural gas has been referred to as a bridge fuel, meaning that in a time it takes for us to make a full switch to zero carbon sources of energy, gas can serve as an alternative to dirtier fossil fuels like coal and oil, which is what you're talking about. That's what your company is all about. While making all this money in this industry, the immediate problem I see is for the bridge concept to not undercut or replace or undercut renewable energy. So how can we avoid, once this gets going and these companies are making their profits, are we just going to forget about renewable energy after that?
Well, I certainly hope not, and I like to think it's exactly the opposite we're doing, because the Blue Fuel project will create an increasing demand on renewables to provide the energy to drive these electrolyzers. We can build them out, or to put the numbers in place, we could put close to 2,000 megawatt of electrical energy into this plant to replace all of the hydrogen, all the natural gas that comes in. That's an enormous amount and would be, taking many, many, many years to be realized. But there is like a sponge that is insatiable for renewable energy. So this project would very much encourage development of renewable energy to replace the gas. And I fully, agree with your assessment there. I mean, we need to go that way. It's taken millions of years to put the non-renewable fossil fuels into the ground, and in a matter of a few generations, we're consuming it all. And there's absolutely no doubt that we have to get away from fossil fuels. But the problem is, try as we may, and we've been using a lot of brain power for many years, we haven't found the ultimate super silver bullet that solves all problems in one shot. Unfortunately, I don't think anybody has. However, we think this project is sort of a gateway to a new future that actually provides a bridge with a pathway how you can achieve it. And it's going to take some time. I wish I was bright enough to come up with the instant solution for all our problems, but so far that has escaped us.
Yeah, I think that most people think that there is a silver bullet, and it's not really a silver bullet. It's a family of solutions, and maybe Blue Fuel is part of that family. And then, of course, there would have to be a way to phase out the production of natural gas once we have crossed that bridge to a renewable future. But, go ahead.
If I may just sort of outline how I see the future coming is that, we all agree that electric cars are the way of the future, but our current incarnation of electric cars still suffer from a number of inherent setbacks. One is that you have to plug them in, and there's a convenience factor, and I think for early adopters they're willing to do this, and I'd be happy to do that, but I don't believe that the masses are ready for that today. And with current battery technology, the range of electric cars is just very limited, and batteries are very heavy and expensive. If you look at the energy intensity of a kilogram of battery versus a kilogram of methanol, you would find that methanol has about 5 times the energy in it, or more, than the best lithium-ion batteries have today. For example, what Tesla is utilizing. Mm-hmm. So our long-term belief for the electric car is that you make renewable methanol, and then have on board a car a reformer that reforms the methanol into hydrogen, and then have a hydrogen fuel cell that generates electricity and have an electric drive car. Now you can have a car that you fuel through the existing infrastructure of gas stations as exists around the world with methanol, which is a liquid at room temperature, and you have a fully electric drivetrain whereby the methanol becomes a carrier of hydrogen. So this way you've solved the biggest problem with hydrogen because we know how to make it and how to use it, but we don't know how to store it.
Mm-hmm.
To illustrate this is something very interesting. We tried to look at transporting some of the hydrogen we're going to be making up there to Japan because Toyota is very much involved in the introduction of hydrogen fuel cell cars, and they wanted to get hydrogen there. And what I learned is that to transport 500 kilograms of hydrogen requires 40 tons of containment vessel. So visualize you have a truck going from A to B. A full truck weighs 40.5 tons, and the empty truck weighs 40. It's a ridiculous concept. However, if you now made a renewable methanol, you could transport this in any vessel that can carry water. Not pressurized, not contained, it biodegrades, it doesn't explode. It's a very benign material to transport. And then transport to wherever you want to go it and then reform it back into hydrogen. Much, much more efficient overall and much safer. And today the technology for onboard reformers on cars is only in its infant stage. I was at the Hanover Fair in Germany in March of this year, and I held in my hand a 3 kilowatt, I think it was 3 kilowatt, prototype of a fuel cell reformer by a Danish company that are introducing a small electric car, it's like a smart car with electric drive and a battery, and this little reformer in there and a small, I think it's a 10 or 12 liter methanol tank, if my memory serves me right. And with that, they got an 800-kilometer range out of a little electric car. That, I believe, is the beacon of the future, because now we can use renewables to make methanol. We can also make it from natural gas, which is still better than oil. And we can now extend the range of an electric car because, as you well know, a passenger car, I mean, we're not talking about taxi, but a normal car that you and I might own, would spend probably 95% of its time sitting around. So while it sits around, it can continue to recharge itself from the methanol, so you always have a charged battery, you don't have to plug it in. And that's where the concept that we use in Blue Fuel of liquid electricity came about. We're using renewable electricity to make a liquid fuel and a methanol, and that's the ultimate. So right now, at the beginning, we are making methanol, but then convert it into gasoline to plug into the existing market, because a methanol market for fuel cell vehicles doesn't exist yet.
Now, one thing that comes up about the fuel cells, didn't Ballard Power Systems in Burnaby, BC, get a lot of money from the provincial government to produce fuel cells and end up not getting anywhere with that technology? Is that the same what you're talking about?
Well, you're correct in that they did get a significant amount of money, and the market adaptation did not occur. Because, again, the one big problem was, how do you get the hydrogen there? They built wonderful hydrogen fuel cells, which have become a very reliable, technologically sophisticated and well-developed product, but the infrastructure isn't there. And that has been the fundamental curse of the hydrogen age all along. I mean, hydrogen is the most common element in our universe, and it begs to be utilized. And while we know how to make it with electrolysis and how we know how to make hydrogen into electricity by fuel cells, we don't know how to store and transport it. Think of the demonstration project that was done for the Olympics when buses were equipped with hydrogen fuel cells and big tanks on the roofs there to put the hydrogen in there. Now, in order to find renewable hydrogen, they shipped it from Quebec to BC, which seemed ludicrous to begin with. And while it was a great demonstration project, it made no economic sense. If you had an onboard reformer and were able to use methanol, the whole thing would be a totally different ballgame. But the technology is, in that regard, on the reformer side, is not as far developed as it is today with fuel cells. To give you another insight into that, Ballard, again, the same company mentioned earlier, has bought a company in the States, and I think they're called Idatech, who make reformers for stationary application to replace diesel generators for power stations for cell towers. Because as you well know, all cell towers are connected to the grid normally, but if the grid goes out, you have to have a standby power generator so you continue to have communication, and typically those are diesel generators. and they're smelly and noisy, and people in third world countries steal the generators and the fuel. So they're switching increasingly over to methanol, whereby you have a reformer, there's no noise, no moving parts, no smell. Yeah. And again, if you make renewable methanol, that's a whole new market opportunity, and that's what we're addressing here with Blue Fuel.
It's a big topic, and I think that even with our talk today, I don't have it complete in my head, but I guess I'm very interested to see what you guys come up with in the future. Maybe check in with you again next year and see what's going on with that. But we better cut it off there as we're coming up on 30 minutes. Any last thing that you forgot to say? Anything you wanted to add?
Well, I appreciate the opportunity to talk to you, and I very much welcome critical questions because if you can't answer them, then there's something fundamentally wrong. And we like to think that we have thought about a lot of things, but you can't think of all things. So we welcome questions and hope we can answer them. And if not, we'll learn from them and maybe can do things better.
All right. Well, I'll get my any questions that come in through my email from my listeners. I will save them for the next time we talk.
Excellent.
Okay. Thanks for joining me.
Real pleasure. Thank you. Bye-bye. Real pleasure. Thank you. Bye-bye. Real pleasure. Thank you. Bye-bye. Real pleasure.